Everyone. We're just going to wait 1 or 2 more minutes before we get started so we can give some more time for people to join. So.
Sweet. Hello, everyone. Seeing some highs in the chat.
Cool. Ready to get started? So welcome, everyone. Thanks for joining us. Today, we'd like to show you how a trusted data platform can be the catalyst that helps you create value from your data at speed and at scale utilizing Apache Kafka and Apache Iceberg to build a real-time data lakehouse. So before we get started, want to quickly cover code of conduct. You can find more information by scanning the QR code. Additionally, there will be some time left at the end for questions, but feel free to drop questions at any time in the chat. The session is being recorded, so we'll be able to share it afterwards via email with some additional links and information. And for today's agenda, we'll start with a little introduction of who we are and what Aiven has to offer. Then we'll get to the current state of the technologies being Kafka and Iceberg, how they're used in industry, and then how they're used together. Then I'll pass it to Douglas to speak on how our solution brings us to our desired state of having a real-time data lakehouse. And he'll also demo this in action. And then at the end, of course, we'll have time for questions. So just a little introduction of Douglas and I. We're both solution architects here at Aiven. We get to work with customers every day, and we've seen firsthand how these technologies can simplify even the most complex data problems. So we look forward to showing y'all how. And a little bit more on Aiven. Aiven's an open source data management as a service platform for any and all of your data needs. Our management delivers high availability, expert support, centralized security, and governance, resulting in near zero downtime during scaling, upgrading, and other management operations. You'll see a glimpse of our platform's capabilities today with Kafka. However, we are also here for your database and caching needs. So before we get into the content, I want to post a poll question to y'all, and it should pop up in the polls. Do you believe that intelligent actions can be harnessed without a real wealth of business data? Feel free to answer yes or no, and then we'll get into the content. Okay, pretty split, 50-50 so far. Okay, so currently a couple more saying yes than no. Give it a couple more seconds. Okay, so pretty split, but most of y'all are saying yes, so cool. Now we'll get into our technology overview. I'm just gonna go over Kafka, Iceberg, what they are, how they're used currently. So starting with Kafka, as a quick overview, it's a distributed streaming platform that handles huge amounts of data in real time, enabling your applications to communicate with each other asynchronously. Its popularity comes from its high performance, scalability, and fault tolerance. It's the backbone of many businesses that need to move and process massive amounts of data in real time. And a little bit more information on Kafka. You'll see the names producers and consumers. Producers write to Kafka, and consumers are the ones reading from Kafka topics. And because Kafka doesn't push data to its final destination, connectors, specifically sync connectors, funnel data out of Kafka taking real-time streams and pushing them to their final destination, all without having to write a single line of integration code. So just showcasing this, you'll see this in our demo later. So that's to note. And then I do have another trivia question for y'all. How many organizations do you think have adopted Apache Kafka into their current architecture? It should also pop up as a poll question. There you go. Okay, so pretty wide range of answers here, and I'll leave it up for a little bit more so everyone can answer. Okay, so most of y'all are saying 10,000 to 50,000 organizations. Well, I'm gonna cut over to the next slide, but it's actually more than 150,000 organizations worldwide that are using Kafka in their architecture. And what we've seen here at Aiven is more than 45% of our streaming fleet leads that data into many forms of lakehouses. So with all this data going into lakehouses, can we tee up the data to be used more efficiently for when it gets sent to the lakehouse? And this is where Iceberg comes in. Iceberg can handle massive amounts of data in petabytes, and the sky really is the limit when it comes to Iceberg. So a little bit of information on Iceberg. Iceberg is an open table format that sits on top of data lakes, giving them the reliability and performance of a data warehouse. So a traditional data lake is just a collection of files, which can make it really hard to manage, use, query, kind of get those business insights that you're looking for from your data. Iceberg just adds a metadata layer that organizes these files into a structured table, providing powerful new capabilities. So we can see that here on the diagram. You have the data layer and then that metadata Iceberg layer on top. And some of the pros of using Iceberg are going to be schema evolution. It can handle schema changes like adding, dropping, or renaming columns safely and efficiently without data rewrites. You can time travel with Iceberg, so it tracks every change in your table, and that lets you query a table as it existed in a specific point of time, or you can quickly roll it back to a previous state. We have high performance when it comes to Iceberg because it's able to improve query performance by using an efficient manifest list and file level pruning, allowing engines to skip entire files and only read what they need. And lastly, interoperability. Because it is open source, it's also engine agnostic. It works with popular query engines like Spark, Flink, and Trino, so you can choose the best tool for your workload. So moving on to Open Catalog, you can't just use Iceberg alone. Having a catalog is basically a metadata management system. It doesn't actually store the data. Instead, it stores the crucial information about the data, like where the files are, what the schema looks like, and the history of changes. So when the two interact, an open catalog is the centralized control plane for Iceberg tables. Some things you can do with an open catalog is you can tell the catalog you want to create a new Iceberg table, and Open Catalog records this new table along with its location and schema. Or when a query comes along, a tool like Spark or Trino asks the Open Catalog for the metadata of the table, and the catalog responds with a pointer to the specific Iceberg metadata file. So with formatting of the data in the lake and the management of the metadata handled, querying the data takes one more step. So that's where query engines come in. A query engine is just a software that processes your queries, such as those written in SQL, and returns the results. It's the component that reads and executes your request to find and retrieve data. So a little walkthrough of this. When you submit a query, it first translates the query language, and then it connects to Open Catalog to get the location of the table's metadata. Next, it uses that Iceberg metadata to identify exactly which data files are required to answer your query. And then finally, the engine itself reads only those specific files, processes the data, and returns the results. So using this stack allows you to harness your data and its insights at scale through a data lakehouse. So a little bit of information about Iceberg in action. With AWS alone running more than 1 million data lakes on S3, using Iceberg has become a norm when wanting to format this data. We see this on massive scales at organizations such as Salesforce and ByteDance that are storing and using their data for use cases such as machine learning. And so now that we have an understanding of Kafka and Iceberg formatting, how it works in theory, the current implementation is a two-step approach. So first, the data is ingested from Kafka topics into a data lake in real time. And then the second step requires Iceberg to catalog the new data and generate metadata files before this new data can be efficiently queried. So the second step, however, is not guaranteed to be a real-time process. So with the benefits of Kafka's real-time data processing being lost in the current pipelines, how can you utilize these two technologies to result in real-time streaming and insights directly into a lakehouse? Well, Douglas has the answer to that, so I'll pass it to him.
Yeah, thanks, Maya. So that brings us to our solution, the Apache Iceberg Sync Connector and Kafka Connect. You can imagine the Iceberg Sync Connector allows us to actually transform the Kafka data into the Iceberg schema. It reads from those Kafka topics, connects to your Iceberg catalog, the storage, and then it creates the schema necessary. This is a little cheesy, but I like to imagine the highway is Kafka, right? Data is moving fast, real time, little cars, buses, trucks flying on the highway. Your exit, of course, Iceberg tables. The Iceberg Sync is the beautifully designed off ramp, clearing traffic and getting your Kafka data into its destination. It truly lives up to its name as a quote connector, bringing together the benefits of Kafka and Apache Iceberg format. So we're going to dive a little bit deeper into this. And hopefully this helps give you a grasp of how you can apply it to what you're working on today. We have this diagram here, and this is really outlining how you can imagine retrieving the data from your database or your Kafka producers, creating topics, and then landing them in the Iceberg tables ready to be queried. The Iceberg Sync abstracts away the complexity of having your own, consumers, manually having to transform the data into Iceberg schema. You would then need to constantly have to monitor all these things, change things based off the Kafka schema changes, and still ensure that you're properly connecting to Iceberg. So the Iceberg Sync actually sits on top of a Kafka Connect cluster, and it does all of this work for you, and you don't have to worry about it. So I'm going to take a pause really quick. Hopefully this gives you a little bit of an understanding of what Iceberg Sync is. We're going to start getting closer to dumping into a little bit of a demonstration, but I'm curious, how difficult do you guys feel like this is to implement? Feel free to just drop in the chat, single word answers or whatever you want to put. Hopefully, again, this is beginning to make sense, but are there barriers to you guys doing this right now, going online, finding the code, implementing it, right? If so, what are they? Definitely worth is thinking about. And so I have a couple easy with Aiven, haha. So a little okay, maybe decent. Okay. So the truth is, it's a little difficult, right? Especially if you're not implementing especially if you're trying to implement something in real time. It's pretty difficult, takes a lot of time, takes a lot of engineering resources, and you have to create the necessities of all of this infrastructure. And so things like backups, disaster recovery, security, updates, monitoring, changing based off of your scale, optimizing for cost, all of these things, they're pretty difficult, and they take a lot of knowledge of the inner workings of Kafka alone, and also Iceberg, of course, to get this to all work. And most teams that are trying to either just do a little side hustle or create a product for the organization do not have the luxury of doing this when they're working on their core product design and enhancing features and stuff. So thankfully, that is what Aiven is for, and that's why we're here. So Aiven is the open source centered data platform. We allow you to easily spin up the services like Kafka, Kafka Connect, and the Apache Iceberg Sync. We deploy on any cloud, and we have that security, monitoring, scalability built in out of the box. For this demonstration, we're going to be spinning up Kafka clusters in Aiven, along with then having Snowflake for our open catalog, and then we're going to have AWS S3 for cheap object storage. Again, we'll get into the demonstration, point out those different things, dive into some consoles. There's lots of different ways to host these different things like Iceberg catalogs and object storages. Companies are actually aggressively pursuing Iceberg compatibility because they know how popular it is and how great it is. So Aiven works with a lot of different integrations to actually make all this work. We work with the Snowflake in this demo, but again, you can use AWS Glue, JDBC Open Catalog. S3 Tables is coming very soon to general availability. But before we jump into demo, the last question I have for you guys is a simple one. Have you used Kafka and or Iceberg before? I'm curious for all the people that are here, is this something that you guys have like hands-on experience using? Or is this something, have you used one of them? Have you used both of them? Um, cool. Okay, so it looks like a good amount of y'all have some experience working on this. So this is really cool. And then feel free to just keep on answering that, letting us know. But we are now going to jump into demo time. And so regardless if this is your first time or something you have done, we are hoping to make this demo feasible for you. I'm going to cover a very high level demonstration, a lot of console play, a lot of pictures. However, we have a GitHub walkthrough and a YouTube video going through that GitHub repo. And so we'll put that into the chat right now. That'll give you all the scripts to run all the code. And again, that video on YouTube, that's more for the visual or audio-based learners walking through it. With that said, though, let's dive into this demonstration. So there we go. And there's the video and the links and stuff. And so cool. So now this is the big picture. There's three major sections of this demonstration. The first one is going to be our data production into Aiven. This is where we're going to focus on how we set up Aiven for Kafka, Kafka Connect, the Iceberg Sync Source connector, and then we're going to make sure we have data flowing to it, either from Kafka producers or databases. The second part is going to be our actual data transformation layer. This is where we're going to transform things into Iceberg format. We'll set up things like AWS S3 object storage, the Snowflake Open Catalog for the metadata, and then ultimately we need to make some updates in that Aiven Kafka Iceberg sync to make sure that it all connects. And then once we have all of our data flowing through into that Iceberg table format, we'll just use a simple query engine to query the data. Again, super simple, very basic demo, focusing on the core infrastructure setup. And we view this as just giving you the core foundation that then you guys can build on top of to make your product glow. And so let's go and jump into this first section, the data production to Aiven. It's very critical to make it very easy for y'all to actually get the data to wherever, from wherever it is to Kafka. We have two main options, right? Kafka producers, or we can use a Debezium Kafka connector to grab data directly from your Postgres, MySQL databases. There are many ways to create Kafka producers, but typically we just can spin up, a Docker container or a Kubernetes service, deploy it to any cloud provider. If you don't want to worry about those Kafka producers, we easily allow for connectivity to databases, which based off of updates and writes to that database, like if you update a product or something, Kafka messages are automatically created with the information and stored into Aiven's Kafka. Then those Kafka messages can then, via the sync, go directly into Iceberg format without any effort on your side. So now I'm going to share my screen and we're going to open up the Aiven console. Sweet. So you guys should be able to see my console now. You can go in and sign up for free right now. At the end of this course, you are going to get a little QR code. It's going to give you $400 worth of credits on our console to go and play around with all this stuff. That should give you more than enough to try out any services. You can press create service, spin up any of these available. But what I want to talk about quickly is just an overview of our console. So when you sign up, you're going to have an organization. And the organization really is like your company or your side hustle's name. And then inside of this organization, so if I click on it, ours is solution architecture for this instance, we then have these projects you can see. And these projects are actually where the data services lay. So you might have inside of here your Kafka services or your Postgres services. So let's click into my project, which is DYoung Demo. And here, via that Terraform script that's going to be inside of that repo, you can actually select the project that you want to pick, and it'll spin the Kafka services up in there. And so we can see our Apache Kafka cluster and our Apache Kafka Connect cluster. Let's click on the Apache Kafka one. And one of the most useful pieces of information is this connection information. Here it gives you all the things for your Kafka producers to actually connect to this Kafka cluster. There's also a quick connect button up here. We can click on that, see and pick the language of our choice, create a topic, create a schema, and connect to the client. Now that we have that out of the way, we can go back into the console and we can go to the Apache Kafka Connect. So let's say you don't want to use a Kafka producer. We want to connect directly to our Postgres database. We would go into our Kafka Connect cluster. We go to this connectors tab. And then as we can see, I spun up all the Terraforms. We already have our Iceberg sync up and running, but I could scroll down here and also add to it this Debezium PostgreSQL connector, press get started. And then I can input all the information here, name it, all that fun stuff, and connect directly to it. Any updates will then create Kafka topics, and it'll all be streamed real time into here. So with that said, I lastly, again, just want to highlight the Apache Iceberg sync that will be set up via the Terraform script. And with that, we can go back to our slides, and we can go to the next step. So the next step will be transforming the actual data. And so we can dive into this Iceberg specific side. There's two critical pieces of this, right? So now we have all of our data, it's flowing good into Kafka, but now we have the object storage and the metadata store. Object storage is a cheap way to store data compared to like a Postgres instance, for instance. And so it's critical for Iceberg, especially you're going to be accumulating all of this historical data. It's critical to have cheapness and durability, which is what object storage allows for. And so in the GitHub repo demo, we're going to be walking through an AWS S3 due to its popularity. On the metadata store side, you need a REST catalog, and we're going to be using a Snowflake open catalog. This is Snowflake's take on creating basically an easy to use interface for the catalog. There's lots of different options as we discussed earlier. And ultimately, you just need some catalog to connect to the Iceberg sync connector. So the setup for this demo, again, is the Snowflake one, but there's also a link to different integrations. So if you're like an AWS only shop, we do have AWS Glue integration. And then we also, you can get excited, S3 tables integration is coming very soon. So now let's dive into the Snowflake open catalog UI. Let me show you what that's going to look like once you have all of that set up. I'm going to share my screen. So this is the Snowflake open catalog UI. And there's two main tabs I want us to pay attention to. There's the connections tab and the catalogs tab. The connections tab will be critical for you to create your principals and your roles to actually connect from the Iceberg sync to this catalog. And then if we go back over to this catalogs tab, this is where the actual catalog will live. And so I created this one called Aiven Kafka Iceberg Workshop. And inside of here, I go to my namespaces. And you can almost imagine a namespace like a database. So you might say like the electronics database, right? Where then I'm going to have a bunch of tables associated with that data. And so I can click into my namespace and I can go to my tables. And you can see here, I have a product table. Now this directly associates with a topic I have that I sent data to called the product topic. So when I click on this, it has all of my column data, all of the metadata necessary to be storing this data in a Iceberg table format. And so now we can dive, and I just want to quickly show you guys, so this is everything you're going to get from the Snowflake open catalog side of things. I quickly also want to share from the S3 side of things. So here in S3, we can see that I have a temp Iceberg bucket, and that is all you have to create in the tutorial. But then once you start processing data through, it's going to start creating all of these folders for your Iceberg format. So I have my namespace here. I can click on my namespace. I then need to quickly sign back in real quick. Perfect. So I'm back in. And then I have my product, which again is our table. And then inside of here, you can see I have my metadata folder and I have my data folder. And so if I go into metadata, that's just going to show me all of these JSON and Avro files associated. You can see the snapshots down here. And if I go back, you can go into the data folder and you can see all of these Parquet files set up. And this is where my data will actually be. But of course, I mean, it's fun to maybe click through Parquet files, right? But what we really want to do is our last step, and that's going to be ultimately querying this data. So let's go to the next slide. Let's query this data. But first, I kind of want to go over a little bit about the query engine again. Hopefully this is another diagram to help you get a better idea of what querying this Iceberg data actually looks like now that we've seen it in both Snowflake and S3. Think of the catalog API again as the Iceberg's librarian helper. If you ask for a specific type of book, like Kafka 101, the librarian will search the different categories of books, perhaps scaling across the room to different section numbers related to tech, diving deeper using letters and books to find something related to Kafka. The librarian or catalog API is the easy to speak to and infinitely wise helper for covering the categories or metadata and ultimately pointing you to that book, or in our case, data. The query engine is then what we use to speak to the librarian or the catalog API. There's lots of different query engines like we've discussed, and I'm curious for everyone in the room here, what query engine is your favorite? Is there any out of the box? I know that, Trino and Spark and Flink, these are some kind of common ones. Okay, seeing some different ones. And then yes, of course, if you've never used one, like feel free to put it there. Awesome. Okay, so it looks like Spark is out on top right now, but Trino's right behind. Okay, and so now we're actually going to jump into the demonstration for the query insights. So let's query this. In the demonstration, the GitHub repo, you're going to be able to just spin this up in a basic Docker container, which is all we have here. All of this again is in that README of how to set this up. So let me share my screen again, and I'm just going to show you what that looks like in action. So let's share. Okay, so you can see I'm in my terminal, just a little bit of terminal play, and we are going to make sure that we Docker compose up. You can see our Trino container is up and running, and then we need to exec into that Trino container. All these commands again are in the GitHub repo. And then now we're in our Trino, we can talk to it, right? So I wanna say, hey, let's just select, if I can type right, select, and you can see I've ran this before, everything from iceberg.electronics. So this is gonna be your namespace. And then you're gonna say your table. I'm just gonna take the first 15. And so then we press enter, it'll go, it'll query. And just like that, now we're saying all of the data that we've pushed into Kafka is now easy to read using basic SQL in in Iceberg format. And just like that, I'm now going to share the presentation again. And awesome. Okay, so that's the fully functioning pipeline. So that's if you go through that repo, if you go through the YouTube tutorial, you walk all through that, you'll have everything set up for getting data in real time from Kafka into Iceberg table format, ripe for querying. And please, again, utilize those repos, ask us questions. Please do not hesitate to reach out. We view this as just giving you this core foundation in place for you to build out your wonderful project on. And then lastly, of course, the QR code to get those free $400 worth of credits in Aiven. Go ahead, start getting set up. Set up a Postgres database, flow that data into a Connect cluster, and then get into Iceberg table format and start querying. But with that said, that's it from us, and we can open up some time for Q&A.
And I think we already got some questions, so we can go ahead and answer those. I saw the first one from Jonathan. He asked, can you sync to Google Cloud Storage as well? I believe that's still in pipeline. That's going to be released soon, but currently we have the S3 capabilities.
Yeah, but GCP is definitely on the next step on the roadmap. We wanted to start out by getting it to work on S3, and then the next one is naturally going to be GCP, and then it's going to be Azure after that.
And then I see another question from Paul. What scenarios do you recommend this implementation? Any situation where you have like large swaths of data that you're trying to query in real time, whether that be like IoT processing, there's real-time analytics, whether that be for fraud detection, risk analysis, kind of all those fall into it, as well as if you're just having trouble querying or trying to understand your data, and there's large amounts of it. But Douglas, anything to add there?
No, yeah, there's tons of different scenarios. And again, I think anything analytical, so anything where you're going to be wanting to take, so let's say you have, multiple databases, right, with different types of information. If you ever want to have one lakehouse of that information where you can run analytical queries on products or user interactions on my website or analytics on, anything regarding anything related to your company, you can store it all. You can take from like 7 different Postgres databases you have that do specific things, and then you can dump it all into S3 in Iceberg format. And then you can run analytical queries on all of that data. And then if you want to make that real time, that's where the Kafka advantage comes in as well. And then I am seeing another question. I want my Kafka to write straight to object storage in Iceberg table format. So that is actually one of the things coming soon. So there's 2 things on the roadmap. One's coming very soon, which is S3 tables, where you can create an S3 table, which is in AWS. It's basically what you're asking for. It's everything formatted. AWS has been really trying to push this out to where you don't have to use AWS Glue plus S3. Instead, you can just put it all into that S3 automatically. And you can connect that by putting that URL into the Iceberg sync on our side. We don't have that quite out for general availability. Right now, it's only in limited availability, but we should be having that out very soon. And then you can do exactly that, put straight from Kafka into object storage. Then long term, okay, so coming out about Q1 of next year or so, there is the ability to change topics, right? So you can actually just like change your topic to an Iceberg topic, and then it will automatically put it into an object storage. You won't even have to worry about any sort of connection details. It'll just automatically be done for you. Maya, I don't know if you had anything else to add to that.
Nope, you got it.
And then, does Aiven use Kafka Connect under the hood? So I wouldn't necessarily say under the hood, because we have to, like, it's kind of over the hood. It kind of is the hood. We do have to create a Kafka Connect cluster. And that's part of what the demonstration actually goes into doing, is creating that Kafka Connect cluster and then creating the connector associated with that, if I'm understanding that question right. And then, yeah, and I see another one on just the going straight into object storage. I want to ditch the Kafka Connect. Again, that's the more long-term play that we're going towards, where we're just, then yes, it'll be a Kafka cluster, not a Kafka Connect cluster. And then that's where you're going to be ditching that Kafka Connect. When we have Iceberg topics, that's kind of the name. It's an open source initiative that we're putting out there for open source Kafka. And we're going to try to implement it on our side and get people's thoughts and opinions on it.
I see a question from Alexandria. Given the schema evolution is managed independently in Kafka's schema registry and Iceberg's table properties, what mechanisms ensure these changes are applied across both systems? Douglas, I believe with the Iceberg sync connector, it's using the Kafka schemas, correct?
Yeah, so so given that schema evolution is managed independently in Kafka schemas registry and Iceberg's table properties, what mechanism ensures that these changes are applied across both systems to prevent data corruption? Yeah, so basically the Kafka Connect is your source of truth. And so you can actually, you can do two different things, right? You can manually go in and you can create a schema, and then it will basically translate these things associated with the Kafka, translate Kafka topic to schema. But what I might recommend for this case where you want to make sure that they're always the exact same is that you are allowing it to actually create the schema based off of the Kafka topic schema or Kafka schema registry. And then that will be your Kafka schema becomes your source of truth to create the necessary iceberg tables. So you don't have like one person updating one and then another person updating the other. And from Kelvin, it looks like you're struggling with some common patterns for creating materialized views from iceberg tables. Users will likely need to transform the data into different views, worried that this will incur a huge bucket input output costs. Yeah, I'm not sure necessarily um, what the exact cost would be like for that and how to like lower that the most. So I feel like we probably have to get back to you on that. And then I see another question on tombstone records. How do we do that? That's another question that I'm not quite sure of. So my understanding of that is that it will delete inside of the iceberg table, but that's something that I have not tested personally yet. But I believe that would be at least my assumption of what would happen. Um, And beyond the steady state stream, what is the best practice for executing a big data backfill without compromising the performance? That would definitely be kind of based off of use case and making sure that you have some sort of steady process to have continuous checks. So whenever you're doing a big backfill, like let's say you want to move from some giant database that hasn't been used before or that you haven't had put into iceberg before that has a bunch of data you want to put into iceberg format, always recommend nice slow incremental changes and then making sure you're monitoring the performance of your queries. There's lots of ways to make sure that you're monitoring your query engines, basically how efficient are the writes, how efficient are the reads that are occurring there, and then making sure that like, hey, that number is staying wherever your performance SLAs are. I think that's most of the questions so far.
I did see one. I don't know if we've addressed this question yet. How would you inject a DBT transform into the data stream? I think including any sort of like enhancement or transformation of your data would require some sort of like either micro batching, whether that be like Flink or Viverita addition there. So something to note.
Okay, looks like we just got another one. That's going to be if my Kafka messages might contain duplicates, how do I ingest them into Iceberg while robustly deduplicating by a specific field on the Kafka messages? Interesting. Okay. Yeah, classic single source of truth problem there. I feel like you might need to I feel like it might be like a use case by use case, but of course you would have to figure out what the actual which one is is it's the ultimate source of truth that you want to go with. Um, hmm.
Douglas, were you done with that question?
Yeah.
Okay, cool. I see Hannah wrote in a question, how does Apache Kafka ensure exactly one's semantics when streaming data into Apache Iceberg tables on AWS S3? I think that just kind of falls into what Kafka is good at and what Iceberg is good at when it comes to being able or like having its metadata driven approach. It's able to track that exactly once configuration and keep it in time. So when data enters an S3 bucket, it's written into the metadata as like a point in time. So you can actually see that exactly once semantics.
Yeah, and then I also now see we have a what are the trade-offs between using Kafka Connect versus Flink for ingesting into Iceberg at scale. Um, so for this, I would say Flink allows you to be very granular in what you do, right? So if you have for instance, and Kafka Connect kind of has these like out of the box connectors. You can also, of course, create your own custom connector. But Flink allows you to get a lot more granular. So if you need to do a lot of very, more complex transactions and stuff like that, I would recommend using something like Flink if you have something simple out of the box, and that's kind of like where, as far as like an Iceberg sync goes, connector, just use a Kafka Connect one and then use that simple out of the box one. But of course, yes, if you were needing to do a lot of different, complex, different transactions on multiple different Kafka topics, and then transform that data somehow into Iceberg, you might want to use Flink for that more granular use cases. Okay, I see another one now. Okay, fun. How does Iceberg snapshot isolation handle concurrent writes from multiple Kafka partitions? So yeah, I might not know the exact nitty gritty details here, but you're going to end up having basically where each writer is. Yeah, I'm not exactly sure, but pretty much the new manifest files and the metadata files will kind of work. I'm actually not 100% sure on this side how it works in like the nitty gritty. But a lot of that is usually handled by the metadata, by the catalog API. And so like again, kind of going back to like the pointer, it's always going to point to the most up to date version. Um, but I'm not exactly sure nitty gritty how that works. and then schema evolution, synchronized. Um, so basically just forward compatibility, like basic forward compatibility, making sure that there's no non-breaking changes. So if you're writing something to, if you're evolving a Kafka evolution, then the same, it works very similarly on the Iceberg side. It inherently supports schema evolution, basically. Cool.
One question from Jade that I see: how does Aiven mitigate latency when scaling Kafka clusters across multi-region deployments? I'll mention one like Kafka cluster, Kafka service is gonna be deployed within the same region across availability zones. So that's one way that we mitigate latency. And when there are like scenarios where you do want multi-region deployments, you'd be using an additional tool like Kafka's Mirror Maker to make sure that you have like replication across regions. So there's that.
Yeah, and then I see another question. Arthur asked, what's the best strategy for managing compaction in Iceberg while handling high velocity Kafka streams? So this problem basically is where you're writing really small manifest files because things are coming in so quickly, right? High velocity. And so on the Iceberg Connect side, when you're working through that demo, there's a field that talks about the fact that, basically it'll pause before writing. So it'll kind of, you imagine like a little batch write. And the higher that number is, so the longer you wait, the more you can kind of slow down this high velocity. But yes, a lot. If you have to have like a really really high velocity, that will create will create some performance issues on the Iceberg side. But they can be mitigated from the fact that you're maybe trying to slow down a couple of those writes to make sure that there's larger manifest files, which is easier for Iceberg to read.
Question I see from Claudia: what's the performance impact of using zero copy Iceberg topics compared to traditional ETL based integration? I don't know if we have any specific benchmarking released yet, but in terms of what the next step is from here when it comes to like connect from the Iceberg connector that we showed today, using the zero copy Iceberg topics will basically make connectors redundant. So you'd be saving a lot there on costs because you don't have to spin up Kafka Connect separately, as well as taking the chunk of what traditional ETL-based ingestion you would have there as well. I see a question from Darren. If you're using tiered storage, how can you migrate to Iceberg or Iceberg topics long term? Iceberg topics aren't out yet. They have a little bit to go before they're available for the public, but we will definitely have migration information there to help guide that, as well as a little bit sooner in the future when diskless comes out, the same thing. And I don't know if we've defined what diskless or inkless is yet in this presentation. It's just writing to object storage instead of on disk when it comes to Kafka topics. So there's more information we can post about that as well in chat.
Yeah, and you can easily see how, hey, with diskless, we're already writing to object storage, and then we can just put it into, if you have an Iceberg topic, you're just putting it into the object storage, but in Iceberg format. Well, looks like that's a lot of the questions. Okay, so okay, here we go. What's the best practice for maintaining time travel queries in Iceberg with real-time Kafka ingestion? So this is a little bit going back to, again, one of the best things you can do is kind of that micro batching approach. If you start to see that you're getting like performance issues based off of whatever you need for your business. And so I think that would just go back to, again, one of the best things you can do is micro batch, increase that number if you need to make sure that you are not like overriding to the iceberg, especially if time travel queries are going to be what you use a lot of.
I think a lot of the questions when it comes to optimization really do come down. I see like how do you optimize partition strategies in Iceberg to align with Kafka topic partitioning? I think that really just depends on what your throughput is, what you're storing, and kind of the schemas involved with that. So it's a very like one-for-one case on what might be the optimized pattern there. Cool. I think there might be some more questions coming in, but I know we're getting close to wrapping up. So any last questions, feel free to drop them in chat. Otherwise, we can always, or y'all can always reach out to me and Douglas individually, and we'll be more than happy to continue talking about it and answering questions.
Yeah, and I do quickly see one more. So how does Aiven automate rebalancing Kafka consumer groups when streaming into Iceberg? So that actually doesn't necessarily change with the specificity being Iceberg. That's still just part of what encompasses Aiven for Kafka. Cool. I think that's all of the questions that hopefully we didn't lose track of any, but I think that's all of the stuff. Well, let's see, wait.
Cool. I think we're good to wrap up here. Again, if anything, my name is Maya Shermley, Douglas Young. Feel free to reach out to us or contact us on or like through the website to answer any more questions. But yeah, thank y'all all so much for joining. Again, the recording will be sent out after this, as well as more information about the, gift card. So we'll have all that for you as well. And all the links as well will be sent out. So yeah, hope y'all enjoyed. Again, thank y'all, and you're able to implement this in your architecture.
Bye.